In Denmark, the goal of a 70% CO2 reduction includes a climate and energy-neutral water sector, particularly wastewater treatment, which accounts for 4% of the global energy consumption, and with it, a high carbon footprint. Treating wastewater properly for the benefit of the environment, their citizens in Greater Copenhagen, and all marine life is of great importance for Biofos, Denmark's largest wastewater utility company. At Biofos, we treat wastewater for more than 1.2 million people each day. Located in central Copenhagen, we are proud to belong to a capital where it is safe to swim in the harbour and nearby beaches. As well as treating wastewater, we are also targeting to combat climate change. We need to reduce CO2 emissions drastically. We can achieve this with innovative and smart thinking on how to lower energy consumption throughout the wastewater treatment process. As well as lowering our use of resources in all areas of the field and produce more green sustainable energy to displace fossil fuels. At the treatment plant, emissions of nitrous oxide are a natural result of the biological processes when treating wastewater. However, nitrous oxide is one of the most potent greenhouse gases and contributes significantly more to the carbon footprint of wastewater treatment plants than both carbon dioxide and methane. We know that microorganisms in the removal of nitrogenous compounds can be derailed in the treatment process and can produce harmful nitrous oxide. Because of this, we have asked ourselves the important question: how can we control and optimize our processes to avoid this from happening? At Biofos, we measure nitrogen emissions from the biological process using different methods. Biofos has installed 4 sensors from Unisense environment to detect dissolved nitrous oxide in the aeration tanks. The Technical University of Denmark is working with a tracer gas method to determine plant-wide emissions of methane and nitrous oxide. And finally, the company Explicit is using drones equipped with sensors flying over and alongside aeration tanks. These methods provide us with invaluable data on our nitrous oxide emissions. We are also working with DNA characterization of the bacteria that form nitrous oxide. Together, all these measurements will provide valuable knowledge to understand the dynamics of nitrous oxide production and elimination. With this, we believe that we can reduce the emissions of this highly potent greenhouse gas significantly and lower the carbon footprint of wastewater treatment plants. Thank you for visiting.